All right, so today we're going to talk about graphs. Okay, we are on page 57. Okay, 57. The first one that we come across is a dot plot. A dot plot, remember when we had, like, I don't know, we measure our pulse rate and we kind of take off, you know, whatever. We put dots for each one, right? We have dots for each one, right? Really, that's what it is? Okay, so look at page, example number 1, page 58. Look at the example number 1. So you see the dots for every one of, what is this? The pulse rates, okay? The pulse rates, okay? So you can see that the x-axis is a numerical value, okay, all right? So if you see there, if you go back to page 57, it says dot plot consists of a graph of quantitative data. So this is specifically for quantitative data. Okay, so a dot plot displays quantitative data, not categorical data, okay? It's quantitative, all right? Okay. Features of dot plot displays the shape of the distribution of data, right? You can get a shape out of it, a shape comes out of it. It is usually possible to recreate the original list of data values, right? Usually you can read it off to see where, I mean, because, right, if you go to page 58, look at that example, you can see, right, where 61, 62, 65, 66, 68, where they actually fall on. So you can usually easily guess what the data is, right? Okay. So the other one that is kind of similar to this is stem plots, right? It's a stem plot, okay, stem and leaf plot. We talked about stem and leaf plots, or no, did we not? We did not? Do you remember doing a stem and leaf plot? You do? Kinda. I find half and half there. So let's go to example number 2. Look at that stem and leaf plot. Okay, there's 4, 5, 6, 7, 8, 9, 10, and then associated with it are the numbers. Okay, so the numbers to the left, on the left-hand column, are called a stem, right? And then the other ones are leaves, because off of a stem you have little leaves, right? So what the stem and leaf plot is missing here, it does not have, what it should have is a key, okay? So if you look at the 4, 0, and 2, those pulse rates are 40 and 42. So traditionally you would have to put a key like this. So I know that the stem is the this digit, and the leaves are this digit, okay? Because for all I know, it could be like this. I do not know, unless you give me a key, right? So this is similar or analogous to if you look on a map. Map has an insert saying that each inch is so many miles, right? It's exactly the same thing. Okay, 40 stands for 40. Okay. So in the future, if I ever ask you to generate a stem and leaf plot, and you do not have this, you will not get full credit. Okay. And you understand why, right? Because I need to know what the data means. Okay. All right. So how do you do a stem and leaf plot? You basically go through the data, and again, you write it off, right? So the data looks like it's going to be from 40 all the way up to what? 102, 104, right? 104 is the highest one. So as you read it off, you will go ahead and just put a mark. So if you get 57, so if I have 4, 5, 6, 7, 8, 9, 10, and as you read off the data, if I have 74, And I put here if I get 81, or if I get 59, right? And then I get, I don't know, 71, right? And if I get 79, or if I get 54, and you just continue to go, right? So what you would end up getting is a 7-leaf plot, but it's going to be different than the one you see there. What would be the difference? How would it be different from the one I see over there?
Some of those are empty.
Well, I mean, because I haven't put all the data in. But do you see how they are unorganized?
Oh yeah, not organized.
They're not organized, right? Whereas the one over here goes from smallest or least to the largest. Okay. So this is called an unordered stem and leaf plot. You always have to go through this phase, right? When you read off the data and you start putting it in here, right? And then you organize the data to look like that one here on example number 2. Okay, in other words, you put them in order, right? So you have unordered, ordered, okay, all right? So that's a 7-leaf plot. So look at that 7-leaf plot. What can I tell about the data? Looking at that data. What can I say now? What is the point of having this?
There's a lot of heartbeats.
A lot of heartbeats, okay.
Their pulse rates in 60 to 70.
Is it possible for me to find the median on a 7-leaf plot? Right, because I go from the least, and then I go inside, right? If I stack it from the least to the highest, and I go like this to find the median, correct? So I can do that in a 7-leaf plot, correct? Can you see that? I have the ability to do that. I also have the ability to look at the data and say, it looks fairly roughly symmetrical, right? Because if I took that 7-leaf plot that looks like this, and I put it like this, can you see that that's basically a dot plot, kind of like? Almost, right? Okay. So I have an idea of the shape of the distribution. I can make a good observation about that. Okay. So those are some of the things that a 7-leaf plot does. Again, is this categorical data or quantitative data?
Quantitative.
It's quantitative, right? Definitely, right? It is not my hair color is black, red, green, or blue, right? It is numbers, right? So it's quantitative, okay? So the 7-leaf plot represents quantitative data by separating each value into 2 parts, the stem, such as the leftmost digit, and the leaf, such as the rightmost digit. Better stem plots are often obtained by first rounding the original data values. Also, stem plots can be expanded to include more rows and can be condensed to include fewer rows. Okay, all right, whatever. Okay. Features shows the shape of the distribution. We talked about that. Retains the original data values. We talked about that. The sample data are sorted. Okay, they are ordered when you're done, right? Not when you're actually building it, right? It's unordered, but once you're done, it becomes ordered. Okay. Let's say that I'm going to do I did a number of home runs per team, for the season, and I don't know, like 40, 50, 60, 70, 80, 90, and 100. So, and I did, so I went to the, okay, so let's say I did the 19 or 2020 Yankees, or all the MLBs, right? All the MLBs, right? And I had 1, 2, 3, 6, 9, I'm just making this stuff up as we go. 75, 6, 81. Okay? So this is the 2020 MLB teams. Okay? So there are 30 teams, so I would have had 30 data points here, right? But I want to compare this to 2022. Okay? So I could make another one for 2022, but instead of making another one, I could also go like this, right? And I can make the 2022 here, right? I can have a 1, 2, 4, 5, 6, 8, 8, 8, 9, 1, 2, 7, 4, I don't know, right? Whatever, right? Okay? And I can actually make a comparison, okay? This is called a back-to-back stem plot, and it's used exclusively or major, or for the major difference here is that I can make in one nice and succinct way, I can compare the years, right? Okay, all right. Back-to-back stem plots, okay, all right. Okay, then we come up with a time series graph. This is very self-explanatory. Go to page 59, look at the example there. It is the time series, so it's something, one particular thing that you are observing over a time, right? So it's 1985 all the way up to, looks like 2015, 2020, something like that, okay? All right. Feature of this, okay, this is also quantitative data, because, why is it quantitative data? Is it because the x-axis is numbers or the y-axis is numbers? The y, right? X is nothing but the time, right? It's the y. Those are numbers, right? Okay. So it's quantitative data, reveals information about trends, and that's basically what they're good for, right? It tells you what's going on with that parameter. And then you have bar graphs. We briefly talked about bar graphs when we talked about histograms. I said where histograms were quantitative data, bar graphs were categorical data. Remember me talking about that? We also talked about the histograms. Each block is right abut to each other. They touch each other, whereas in a bar graph they don't. Okay? So go to bar graphs. Bar graphs use bars to show categories of categorical data. Okay, feature of a bar graph shows a relative distribution of the categorical data so that it's easier to compare in the different categories. And then underneath that there is the Pareto chart. Pareto chart is nothing more than a specific bar graph. In the Pareto chart we put the most on the left, and it sort of comes down and it goes down like that. So go to page 60. If you see on page 60 there's a bar graph, but the bar graph has from the left, it is in descending order, right? It's in descending order, right? You see that? Okay, that's what's called, so because it's in descending order, it's called a Pareto chart. Now, is this quantitative or categorical data? It's categorical data, right? Categorical data. Okay. Then you have the pie chart. We talked about pie charts, did we not? Or did we? No? Pie charts, you're used to seeing pie charts, right? Is this categorical or quantitative? Categorical, right? Categorical. Your favorite rock station, your favorite radio station, the color of your hair, right? Those type of things. Again, categorical data. So which ones, going back that we've talked so far, do quantitative data? The dot plots, stem and leaf, what? Time series. Okay, histogram does, but we didn't talk about that today, right? Categorical data. and pie chart, and the special kind of bar graph is the Pareto chart. Okay? All right? All right, stop right here today.